Hello there. A couple of weeks ago, I had a circuit board manufactured by JLC PCB and shipped to me here in this US for about total costs under $12, $11.80 or something like that. So the shipping using the cheapest shipping carrier they had was only about $3.80 or something like that. It got here in 10 days. I mean, what a great deal. So I got 10 little boards, and let me show you these. Okay, so this is what the board looks like. There's two of them there. A single one looks like that. Now, when I bought these boards, I opted not to get the solder stencil because JLC PCB's stencils are very large, and they put a couple of layers of chipboard on either side of it to keep it from getting damaged. And that creates fairly heavy weight. To ship the stencil would have cost me about $20, plus the $7 to manufacture would have added about, getting close to $30 to my $12 order, making it a $42 order instead of a $12 order. And I just didn't think it was worth it. So I decided to see if I could manufacture my own solder stencil. I figured that I had a 3D printer, and I saw that people were 3D printing stencils, but I didn't think that would work. I figured they would be really too thick. But I have a Cricut, or my daughter has a Cricut, and I thought, well, maybe it's a little small, but maybe I can cut solder pads in something, paper or plastic, with the Cricut and make my own that way. So I experimented around with this. I looked all over YouTube, and I actually didn't find anybody using a Cricut to cut stencils. So that's why I decided to make this video, because I was successful finally. I tried using cardstock. That did not work. The solder paste would not flow through it easily enough. I tried to use cardstock laminated in plastic, and that didn't work. And finally, I came up with a piece of laminated plastic that it's just empty. I just ran it through the laminator without any paper in it. You can kind of see the little holes in there up against my face there, I think. I'll show a close-up of that. I'll insert a little picture here to show you that the things are in there. So what this video is going to be about is the step-by-step I took to go from a design of a circuit board in KiCad to a stencil that actually worked. And this little circuit board is used to manufacture this little dice rolling game. And I mean, the lights are, there you go, that looks pretty good. If I punch a button, it'll roll, that's a 20. And it'll roll, and I got a 17. Now this button is a 12, so it'll roll a 12. Now 12, that's a multiplier. I didn't want to multiply, so I got a 4. This button is 10. Or double click for 100. And the 20 can double click for advantage 20, or triple click for a disadvantage 20. And if you play Dungeons and Dragons, you know what that means. And if you don't, you should take up some Dungeons and Dragons playing. My son is a Dungeons and Dragons dungeon master, and he uses this dice thing to help play his game. So anyway, that's why I had the board built. So let me get down to the actual important stuff and show you what it took to get this manufactured. So here you see the circuit board. It has 3 displays. It's got a microprocessor in the back. It's got the 6 buttons. It's got some resistors, some MOSFETs, and some more resistors over here. Now, if I zoom in on resistor and this MOSFET here, you can see that I have like a special footprint. If anybody's built circuit boards, if you're looking at this, you're probably building circuit boards because nobody else would care about solder mask or solder stencils. So I custom built this footprint so it could hold either a surface mount component or a through component. Same thing with the MOSFET. It can hold a through component or a surface mount component. And so I wanted to make a stencil that would work for this board. So we need to save out the footprint of each of the SMD solder pads. Now, my solder pads are unique because I custom built them, so they will have to be edited later on. More than likely, yours won't. You can just export these and use them right away. But I'll show you the editing process just so in case you have to do it, you understand. So to save them out, to start off with, you go to File, Plot, and you pick either your front paste or your back paste, depending on where or both, depending on where your solder pads are that you're going to need a stencil for. And then you just plot it out. And it saves it to this location right here on my computer. You set that up. But anyway, I'll go over and pull that into Inkscape so I can edit it. So here we are in Inkscape. The file has opened and you can see all of the solder pads with the little extra lines on there. I have to delete those, but since this is a vector graphics file, I can use the nodes tool to pick the nodes that I want to delete. And luckily these are combined together, so one click and you get the node. Now if you hold down on Shift, you can click multiple nodes and then delete them all. I'm going to zoom in on this a little bit to make the selection easier, and I'll speed this up so you don't have to watch it all. Now to delete the nodes, you actually have to go back to the arrow button and then hit the delete key, and that deletes them. And then we'll pan over to the other side and we'll do the same thing to these. Select the node tool, pick the nodes. Oops, hold the Shift key down. Okay, those have been deleted, and now I just have pads. And at this point, I could almost consider myself done, but there's one other thing that I want to do. You notice that these pads are really narrow, and I'm afraid that the Cricut wouldn't be able to cut something that narrow and have enough of a gap there to actually push the solder paste through. So I want to make those pads wider. And there's several ways you can do that, but the easiest way for me is to just copy the pads and overlap them. So to start off with, right now, this whole block is grouped together. So I'm going to ungroup it just to get the individual pieces. Then I'm going to take these and I'm going to group them back together so that I can work with just those. Now, so that I know where the center of my thing is, I'm going to drag a line out from the, oops, too high. And I'm going to drop this approximately in the center of these pads. Not real critical, but anyway. Then I'm going to take the pads, and using my arrow keys, I'm just going to step them over a little bit. One notch is probably good enough. And then I'm going to, actually, let me move it over too. And then I'm going to copy these pads with a Control-C and a Control-V. And I've got the pasted copy here. And I'll just drag these over. And then I'll use my arrow keys to step them over. And there you go. That's good enough. I got nice, nice wide pads now. But to make the cutting right, I need to turn each of those pads into an individual node and not two different nodes that are overlapping. So what I'm going to do is I'm going to select all of these. I'm going to, let me see if I can do this without ungrouping them. Let me go to the node tool and go to path union. Nope, it didn't look like it did that. So we'll go to object, ungroup, still grouped, object, ungroup. Okay, now we got nodes. Okay, so path union. And if I zoom in on that path, now you can see that's just one path, not two. Okay, now I'm going to take everything and group it back together. This is a very important part. Now, object group. And the reason this is an important part is you need to know how wide this stencil is. And if you look up here at the width, it's 90.32 millimeters. Let me change that to centimeters. Can I change it to centimeters? Because Cricut works in centimeters. So this is 9.032 centimeters. So I'll write that down, 9.032 centimeters. And now all I need to do is save this. So we'll do a file, save as, and I'll call this dice video, for lack of a better. And I hit save. So now I can bring up my Cricut Design Space. And I'll start a new project. I will upload. Oh, upload image, browse. And I select dicevideo.svg and open it. And here is my file. Now, when this file comes in, notice it is 29.21 centimeters, which is massive in comparison to what it needs to be. Now, I'm already in centimeters, but in case you were in inches, the way you change that is you click on your name up here and go to Settings and Canvas and pick metric, or it will be on imperial if you're saying inches, pick metric. Okay, so now to change this size, all I have to do is go up here and put in 9.032. Come on. 9.032. And there it is. It's now the correct size. So now you can just hit make. I don't have my Cricut hooked up right now, so I might have to hook it up. Um, I forgot something. If you look here, you'll see that those came in all in a row. That's no good. So I need to go back. If I had unioned all of those together when I was over in Inkscape, it would have been correct. Because you can see that this block right here, those I union together. So they're all good. But the rest of these are separate pieces. But you can fix that here in Cricut Studio. So let me cancel this. I'll select all those pieces, hit combine down here and weld, and that'll make them all one piece. And then I can hit make, and now it's correct. So you can drag that wherever you want it on the canvas, load your plastic sheet, and hit continue. And here's where I think it's going to fall apart because yeah, I need to get a machine hooked up, otherwise it's not going to let me go any further. So let me hook up a machine. I'll be right back. Okay, I've got a Cricut hooked up, so we'll try this again. Hit continue. Okay, so now for material, I'm going to hit browse all materials, and I'm going to come down here, and they have a setting for packaging plastic. You know how you get the little annoying ink cartridges or whatever, and they're packed in this really thick plastic that it's so they have a setting for that. Plastic packaging. And the reason I picked this one is because this one will cut twice around, and I wanted to make sure it would get all the way through the plastic. So the last time I did this, I also set the pressure up to more. I'm not going to do that this time. I'm going to leave it as single, just to see. I got the same piece of plastic loaded on my mat. It's just turned around. Okay, I've got my mat loaded. Okay, it's ready. I'll hit go. Now you notice it's cutting, lifting, setting back down, and cutting a second time in each location. One other thing I should mention is that you have to use a sharp pointed cutter blade in here. There's 3 different angles of cutters. This is a 60-degree cutter, I think. I'll show you the blades after I get done with this. Okay, hopefully you can see this. You can see that some of those dots have fallen out already. The others I'll have to punch out with a little pin or something. Toothpick will knock them right out. And there you got a perfect mat. Now, I'm not going to actually make a board right now and put the components on it and flow it. There are tons of videos on the web of people doing that, and this mask or stencil works just like all the rest of them. Actually, being clear makes it a lot easier to align on one of these little boards. I'm going to go ahead and see if I can snap a couple of close-up pictures of the bottom of or the board where I've mounted the components on this particular board. I don't think this will get it close enough to see. I mean, you can kind of see it there. The components are perfect. There's just the right amount of solder to solder it on. It really worked good. So if you look at how do I get my fingers to work? If you look right there, you can see the MOSFETs and the transistors, and they're really good. I'm going to try and take a close-up with my phone, and I'll go ahead and insert that in here too, so you can get a real good close look at what the solder joints look like. So that's it. So this is a pretty easy process. It's cheap, costs nothing. By the way, you can also buy Mylar in different thicknesses that'll probably do this job better. I just happened to have this on hand, and I didn't have any Mylar on hand. I didn't have any plastic things from Costco or anything on hand either. I've seen people, there's a lot of videos out there about making stencils, butterflies and hearts and things like that you're going to brush paint or whatever. And if you watch some of those videos, they'll give you some good ideas of what kind of materials are available and what you can use. Like I said, this is just what I had handy, but it worked perfectly the first time. Well, not the first time. I did like 3 or 4 failures before I got it done. But once I got the right thickness and the right material, the first cut worked flawlessly when I actually did the reflow. So that's it. So I hope this helps out somebody. Thanks a lot for watching. I almost forgot. I promised I would show you the needles you can buy, or the blades. You can buy these blades on Amazon. They're really inexpensive. They come in 3 sizes, 30, 45, and 60 degree. So the 60 degree is the sharpest point, and that's what I use to cut this plastic. It actually tells you to use one of these sharp pointed blades when you're picking your material in the Cricut Design Space. So if you don't have a set of these, go to Amazon, look them up, and buy a set and change out your blades often. It'll make your cutting so much easier. So that's it. Thanks again, and have a good day. By the way, one more quick little thing. This is my mat after I got done cutting the stencils, and there's something I need to point out. When using clear plastic, it is possible for little pieces of plastic to stay stuck to the mat, and they are completely invisible when you just look at the mat. So make sure you scrape your mat really well to get all of that stuff off of there. Otherwise, you're going to be left with little pieces of plastic underneath your next cut, and that's really going to mess you up. Anyway, thanks a lot for watching.